background noise on my side. I'm actually at a conference right now, so I will try and be on mute as much as I can throughout the call. But we're fortunate to have Clay Woolham from one of the Civic Bridge teams at Google, who's done some work with San Francisco 311. He's going to be presenting some of their work today, and after that, I think we'll have some time for questions, and then we can open up for some sort of follow-up and broader sort of just general discussions on ongoing work within the Open311 community, perhaps some more updates on work around the bulk data spec and things like that. But since we have a number of folks joining, probably some folks maybe joining for the first time, if you'd like, it'd be great to have you just mention quickly just your name, your affiliation if you'd like to, and just quickly, yeah, we'll just go around. If folks wouldn't mind just quickly saying that. I realized I did not join in the normal telephone bridge line. Hopefully that's okay. I'm just gonna assume that everyone knew to join the Hangouts exclusively this time. But I will monitor my inbox and things like that if people have trouble connecting. All right, so with that, so I'm Phil Ashlock in the General Services Administration, mostly focused on data.gov. And I'll just go left through right from the names that I see in Hangouts. Andrew Nicklin.
Hey, this is Andrew Nicklin from Johns Hopkins University. You'll see me on twice because I'm trying to help Phil record the session as well.
Andy? Ben? Everyone's on mute, maybe. All right, so maybe the introductions are not going to work so well. Maybe we can save that for later if folks want to introduce themselves. But yeah, with that, Clay, feel free to just take over the presentation and maybe introduce yourself a little bit, and we'll go from there. Thanks.
Hi, my name is Clay. I am a software engineer here at Google. We also have Thru, who is was one of my teammates. She's also on the Hangout.
Hi.
Do you want to chime in, Thru? Yeah. So we basically kind of volunteered with a program through the city of San Francisco called Civic Bridge, which is a program, private-public partnership program, where kind of private sector employees volunteer 16 weeks at a time to help out with some critical city cause. We worked with the SF311 department, and we worked with Andy, who's also here on the call, which is good. And I kind of have this informal presentation, a collection of slides, and I'll talk for about 10 minutes, and then we can kind of have maybe open discussion. If anyone has questions, feel free to ask at any time. Cool. Yeah, like, let's see. We started out specifically looking into the problem of kind of misrouted queries, and for service requests coming in through the mobile app. This chart, the background is actually a graph. It shows like request growth for 3 data sources: the call center, mobile, and web. The mobile app in San Francisco launched in 2013, and the request volume kind of has overtaken the call center, which gets about 300 to 400 requests per day. And now, you know, mobile is the greatest driver of kind of requests. Let's see. So this is the app that San Francisco uses. it is kind of an app made by Connected Bits. It might be familiar to most people here. You basically click new request, and a list of categories will pop up, and you can pick, suppose you're reporting a broken streetlight, you can go and try to find a category that fits the broken streetlight problem. Let's see. So I guess how did we kind of approach the problem of misrouted queries? I guess first we talked to a bunch of people. The San Francisco 311 set us up with a bunch of ride-alongs and give us an opportunity to kind of directly go into the field and meet with the Department of Public Works, the sign shop, and a private company called Recology, which does trash for San Francisco. All three of these organizations handled 311 service requests, and they all had kind of similar and different issues with service requests coming from the app, and we kind of saw some of these problems firsthand. One of the interesting things, we kind of went with the litter patrol route for the Department of Public Works. And we got to see how they kind of get a stack of papers and they kind of go through the stack of papers as they're driving around trying to pick up trash that people have reported. And then some of it's kind of critical. There's medical waste and stuff that has to be picked up pretty quickly. One kind of interesting thing that we did notice was these papers had kind of a URL printed on them. There was a link to the image that was taken in the mobile app. So it's kind of it was interesting, not very helpful thing for these city workers to look at this text description when the person that filed the request attached a photo and it didn't appear on the paper that was out in the field. Let's see. So I guess after we kind of did a bunch of interviews, talked to people, we did a deep dive into the data. We really kind of analyzed how different requests were routed, and we had this knowledge of how these specific departments worked. We ended up coming up with kind of a simplistic definition of what is misrouted. Basically, if a request starts at some department, ends at a different department, we consider that misrouted. It may seem like a bit simple, but it took a lot of kind of teasing out. It was kind of an invention of what is considered a department. We did a lot of kind of cleaning of data and stuff like that. We kind of used this definition to build a dashboard of kind of how requests are rerouted and what do misrouted requests look like. So as you can see here, we can click what we call a queue or a department. You can see kind of how many requests that go into that queue first end up in a different place. That's a misrouted percentage. We can see latency metrics. And on the right side, we can really drill down onto what the specific service requests that are misrouted are. And that's really useful because, if something comes to a place like the sign shop and it goes to the parking meter department, then we can look at like what's the content of that service request and what makes it go to the sign shop first, maybe, and why didn't it go to the right place the first time? All right. Another thing we kind of did with the data, we as a prototype, we made this kind of machine learning model, which looks at the text descriptions and it says, hey, if the text description says something that is highly predictive of maybe the request should go to a different place, then send it to that different place. This kind of showed a 30% boost in accuracy. The example on the slide is something comes into the sign shop, and if it says it's a faded curb, send it to the paint shop. If it says the word meter, send it to the meter queue. Let's see. Great. Another thing we did was kind of like made prototypes and thought of UI improvements. So on the left side, we see an image of what the app looks like right now. This is the list of categories immediately after you click new request. And on the right side is kind of a hypothetical mockup that we made, but it's kind of simpler. It's easy to see. Hey, like I'm filing this service request. I want to go to parks. It's just a hypothetical. We did find a kind of useful tool to kind of test different UI ideas. This tool is called TreeJack. So basically, you can give a short quiz and ask the user to kind of categorize a service request. I might say, hey, you come across a broken street light, and you want to file a service request in the app, and you can kind of drill down in the menu system. The left side shows the current menu system, and the right side shows kind of a hypothetical thing we came up with. We asked a bunch of people to kind of do our quiz, and we found that our kind of hypothetical mockup got a dramatic increase in both user speed, like they found their solution faster, and the accuracy of where they were filing their request to was approved. Our hypothetical mockup cheated because the app doesn't let you have a 4-level deep category system. But the interesting thing to us is kind of having a measurement, having a way to quantify, the improvement of these types of changes. This is a slide showing the results from our experiment with this tool called TreeJack. And the kind of final thing that we recommend was having a end-to-end user satisfaction metric. So once a service request is closed out or finished in some way, the user gets a survey, and they can say, hey, I'm happy with how my request was handled, or I'm mad about it or something. This is a kind of an example of a mock-up what the survey may look like. And that is about all I had. I did skip over a whole bunch of stuff, to be honest. But I did want to just kind of have more of an open discussion if anyone has kind of similar issues or problems with request routing stuff.
Great, thanks. Just before you open up, I was just curious if Andy, if you want to say if you had any remarks just from the city's perspective on this work. You'd like
I mean, I think first we really want to thank them for what they did. It's always good to have someone else come in and take a look at what you're doing. And we acknowledge that, like, from the menu structure, that we're trying hard to go back and fix it, but a lot of our menus are tied to old forms that are all built in city speak. So really working to try and realign those values, and we're still working with the Google team for another month or so, and so we're working together to try and come up on how to improve the menus to try to get people to pick the right thing. Like Clay said early on, we've got a number of requests that go to the wrong place, and part of that is because we have people are requesting services that aren't in the app, so we find they just pick something that's close, and so we're trying to see if we need to expand what's in there. So it's just a good examination of what goes in, and we're looking forward to using also that reallocation tool that Clay demoed, where it says, okay, here's where, if you take this work queue where we start work, where is it winding up? And I mean, our goal is to have all the work wind up, stay in the queue it starts in for efficiency. So some really good tools and a lot of really good feedback and just that outside perspective. We haven't been able to implement the new menus yet. We're working on them, and we're also working on that kind of machine evaluation of, hey, if you sent this to the sign shop, but if the request contains the word curb, let's move it somewhere else. So just give us some ideas of how we can improve on that. So yeah, thanks to them, and we're still working on implementing, but it was a good project. It is a good project because we're not done.
Yeah, it was fun for us. I guess the thing I kind of want to maybe that I didn't emphasize was kind of just having maybe hard metrics, and then hard metrics that you can look at maybe improvements or regressions, and kind of making decisions based on that stuff. Philip, did you want to add anything else? Or,
well, I don't have any remarks or questions from myself at the moment, but I think we're happy to open up the floor for anyone else who might have questions or comments. I'd say go for it. Anyone?
Hey, this is Andrew. I had a question about, you mentioned that you were looking at some machine learning to help kind of deal with misrouted requests. Although it seemed like the mechanism that you were using, I mean, the way you were explaining it seemed relatively simplistic. So I'm wondering, like, how is the machine learning mechanism working? Did you feed it like a training set and give it like, sort of where it was originally routed to, the raw data, and then where it should have been routed to? How did you train it, and how does it get implemented now that it's kind of been trained?
Yeah. So go ahead, Clay. I mean, machine learning may have been a bad phrase for it, because really what we're looking to do is knowing and understanding what some of common errors are. Is we're looking to intercept those errors using our integration service. So I guess based on what we learned, we're trying to have a machine intervene. So I don't know, Clay, if you want to talk any more about that, but yeah, machine learning probably not the right phrase. It's machine intervention based on what we've learned.
Yeah, so yeah, I did kind of create a data set. I kind of took like a sample of service requests from the last year, coming from the mobile app. I did some kind of cleaning. I tossed out service requests that kind of went to like very low volume kind of places and said, hey, like, can we reclassify stuff in the top 5 categories of like the top 5 work queues or departments, and then I like did some standard like natural language stuff. I also I do have a bit of a background in this stuff. I kind of translated the text descriptions into kind of computer representation, and then trained a couple of different algorithms, such as naive Bayes and decision trees and stuff, and then kind of split up a training and test set, and then evaluated the performance like that, which kind of has issues if it's not directly hooked into the system. So I just intended it to be a prototype. I think it would take a lot of kind of expertise to set up and maintain this type of system, which is maybe out of the budget of a lot of city governments and stuff, you know, for these types of problems. But that's basically kind of how we approach that.
Yeah, I mean, I could see a really interesting scalable solution where, you know, kind of a layer. One of the great things about sort of working through the Open311 API or just APIs in general is that you can kind of insert layers pretty easily, and as long as they're compatible with each other, you know, the end clients don't care. So it could be a relatively small, or relatively trivial matter to put in like a machine learning or, you know, sort of better educated routing layer that then connects into the city's Open311 API. So you have like a middleman pass through that can do a little bit of processing and deal with some error resolution stuff. So that's a really interesting concept. Anyway, thanks for the info.
Absolutely. I think there, you know, if to go into this space, there might be a lot of potential for kind of assigning different types of metadata. So you know, if service requests come in for maybe San Francisco has homeless issues, so maybe some need to be identified as a more critical or emergencies or something. So these are also areas where kind of like automation like this could potentially identify things that might be higher priority and stuff like that. So yeah, I think there is a potential for kind of the stuff to be useful and more than just, you know, routing accuracy.
One last comment from me is I used to work in New York City, and I think I see Chenda on the line, but one of the things that I had always wanted to experiment with was doing like image classification. So being able to take like an image that somebody uploaded and say, oh, that's a light pole down, or oh, that's a tree blocking a driveway, or a car blocking a driveway, or things like that. So I think there's also opportunity for image recognition in this space as well to help classify service requests.
Yeah, so we also wanted to do that. We just didn't have time. Google has a API. It costs some money to use, but you can send it images, and it'll send you kind of a text description like that, and it'll say, "Hey, this is a photo of a dog catching a frisbee," and stuff like that. And yeah, I think it would be interesting to see, how useful that would be. Also, just doing that, and then maybe putting that description on information paper for field workers. It might be a photo of a syringe, but it might not say that in the text description of the service request. If the kind of computer vision thing could figure out that there's a syringe there, then it would be helpful for kind of these field workers to know about.
Those are good. We've tried looking at a few of those, and most of them aren't really able to differentiate between a street and a pole and a curb and stuff like that. But we're still looking for adding that, visual identification of a photo, and adding that to the logic.
Yeah, Andy, have you looked into the Google's thing? Yeah, no. I guess
I tried Watson and a couple other services that are available. I'll take a look at yours and we can talk offline.
Cool.
Thanks.
Yeah, I don't work on any of that stuff. Not trying to hawk Google stuff here or anything.
Yeah.
So there was some discussion on the mailing list over the past month or so on just the general sort of issue around how best to group or provide some hierarchical structure for the kind of menu options in the list of sort of service types. And yeah, I don't know if there's, I mean, maybe you touched on this enough already, but is there any thought on sort of like what like the threshold and usability is in terms of how much depth or complexity you provide there versus like how sort of I guess the distinction between how granular you allow things through sort of the tree structure versus the articulation of the description up front. I'm just kind of curious to discuss more like what the limit of depth in a sort of tree menu structure should be.
Yeah, I think Thuru might be able to speak to this a little bit better than me.
Yeah, I don't know. It's a tough problem, right? Like on the one hand, you want the user to help you as much as possible in classifying things. Like if they know that something is, a street light or something, then it helps for them to tell you. And on the other hand, you can't really trust them to choose the right category. So you need to have some kind of robust way to route it to the right place, regardless of what they choose. I think the best way to address this is by doing a lot of user testing and just seeing what different combinations of that, how that actually affects the routing rate. So one of the things that we like to do at Google whenever we make a change is to make some kind of A/B test and do experiments to make sure that the change affects things the way that we predicted or that we want. Yeah, so the short answer is I don't really know what is the right level of depth for menu complexity, but I think we can figure it out by trying different things and seeing how they work.
And does the card sorting thing stuff help with that?
Oh, right. So there's like a lot of UX software. So there's this technique called card sorting where you present people with a list of topics and you have them group them into whatever seems natural. And then you can take a look at that and see how closely it reflects your menu structure. And then, and then test what would happen if that was the menu structure, and then kind of go back and forth until you get to some sort of optimal state.
Hey, this is Chenda from New York. I'm trying to use two ways into this, so hopefully you guys can hear me.
Yep.
So as far as what we're doing on our end, we have multiple ways in on the website, and well, the call center is less relevant, but we're we're redesigning the mobile, and we do have a pretty long menu list. We've been trying to roll more things into submenus once you make a choice. So at least you're doing it in the context of the request. You're saying the snow is here. Once you've said on sidewalk, you're making the other choices about which kind of sidewalk it is within the snow context. If only to reduce the menus a user who's less interested in snow is looking at, because you're not really getting them until you go through the first point. The
Right.
other thing, I don't know if you guys, San Francisco, have a search. We're introducing a search, and just in the user testing we just did, some A/B testing, and we've done card sorting, we've done like lots for this one. Users were so excited about the search, which I think we can all thank Google for that. But it really, which I feel like search on mobile is hard, and it's not a natural. But it was surprising to our team how excited people were, because we had sort of thrown it into the design as to see what reaction we got. And I think that the reality is people want to search for the term that they think is the problem is. So we're going to see how that turns out. And that'll be a big departure for us, because we are exclusively like tree menus now.
So I mean, search is an interesting concept, and we're looking at that as well. And in the application, you're not really limited to just 2 menus, but the Open311 API does just have the concept of the group and the service. So we're trying as hard as we can to redesign or design the menu structures and the services so that any other third-party app that picks up the API gets the benefit of our improvements. So because I know that Clay mentioned we started in 2013, which is true. That's when we actually went and worked with connected bits. We've had the Open311 API since 2010 when it launched, and so we don't want to design or redesign everything that's based on just a proprietary search or a 4 menu level structure. So that's one of the things that also complicates it. But we are looking at mobile web, and we're looking at search, and just trying everything we can to improve that experience as much as for the departments as the public.
Is there anyone who's implementing the Open311 API that's made very extensive use of the keywords associated with services? In terms of, I'm just thinking whether that's to help provide more potential matching search terms if you're using search, or if you're providing something that is basically like a menu structure that allows you to have multiple routes to get to the same thing, which, I mean, I think is something that could at least be accomplished in part using a combination of keywords and groups and other sort of descriptive fields for services. But I'm just curious if folks have experimented with that based on the options that are currently available in the API spec. Maybe not. It's not anyone here today. All right. Well, this I think it's good. Good material to follow up on that discussion that already started on the mailing list. And I think having more mock-ups and user testing, sort of experiment different options, see how much can be accomplished with the current spec versus things that could help improve the sort of simplicity, usability, accuracy, and everything. Certainly more to consider. Any other questions? All right. Well, if there aren't any more questions for Clay or Taru, your colleagues, I guess take a moment to thank you. Thank you so much, Clay, and for taking the time. And I'm sure this will prompt more sort of questions and discussion that we'll continue with in the group. You're welcome to stay on the call and the Hangouts. I think we're going to open up for some sort of broader discussion around some of the ongoing technical work and other things like that. But yeah, thank you.
Oh yeah, thanks for having us. Yeah, it's fun for us to kind of talk a little bit about some of the stuff we did.
Right, yeah, and we'll, I mean, if it's all right with you, we'll plan to share the screen recording of this as well. Great. Thanks. Well, thank you. So yeah, I didn't have a real set agenda for further discussion topics, but the standard, I think ongoing work applies around things like the bulk data spec. I don't know if Andrew, if there's anything you'd like to touch on with that work, or additional folks adopting it, or other tools. And I know there was a blog post not too long ago about some of the sort of data visualization that you guys are doing based on that, but just on the bulk data spec work. Andrew.
Yeah, thanks, Phil. Sorry, actually, it's been kind of a slow month. So since the last call, there hasn't been much in the way of updates. I am continuing to be very interested in building a data validator, and so there's a document on that I shared through the listserv, through the email list or whatever, that I would love for people to go into and just have a look at. And basically, what that document does is describes the kinds of tests that would be done upon the bulk data to number one, determine validation to the spec directly, but then number two, to look for potential quality issues. And so quality issues might be things like you have dates that are incorrect sequentially, or that you have status values of closed but then no value in the closed date fields. So things that are kind of like more consistency checking. And then we'll just, we'll write probably in R, just because that's what the tool that I'm playing with at the moment. We'll write a validator for it. And then figure out a way to get that online and get it in a way that people can just sort of take data and upload it to, through the validator and get an answer back as to whether it's good or not. And maybe some recommendations on how to make improvements if we get to the quality checking stuff as well. So that's kind of where we are. As Phil mentioned, we did do some data viz stuff. That was more just to showcase the idea that now, since we've got multiple cities that are publishing data in the same way, this is particularly in Louisville and in Bloomington, it's really easy to take a simple R script and apply it to both data sets and do visualizations, do the same visualization for both data sets with, basically trivial changes. And I'm very interested also in taking a look at a lot of a few years ago, Code for America did a bunch of work based upon the Open311 spec, and I'm very interested in seeing if maybe some of the tools that they built there could be ported over to support the bulk spec as well, so that way that kind of incentivizes more cities to start publishing in it, because then there'll be a sort of a suite of tools at their disposal, kind of out the gate, to be able to analyze, or to just be able to get better insight into the information they're sharing. So that's kind of the status update from our end. Nothing particularly crazy.
Great, thanks. Yeah, on the topic of some of the tools that Code for America developed, I remember there was, I think, a number of those, or at least a few of them were using like a MongoDB API, I think, for doing some kind of like statistical analysis. And I've been trying to actually like dig that up in GitHub or wherever it is now. But I mean, I think there were some things in that could inform whether it's ongoing sort of evolution of the bulk data spec, or if there's actually extensions to the API that allow some sort of statistical queries, in real time for the kind of longitudinal, historical data. What was that? Yeah, thanks for the update, Andrew. Anything else folks want to talk about? Update? All right, yeah, I don't have any other updates on my end. I am a bit behind in uploading the presentation from last time. Just had a few edits to make in that before uploading it, but I'll be sharing that shortly. And this one should go up pretty soon as well. Also, continuing to look for other folks who are interested in presenting in future months. I think we have 1 or 2 lined up already, the next couple, but happy to sort of build that queue if there's things that folks want to demo or present. Yeah, otherwise, hope to continue providing additional updates around, the sort of the core API validator work, and improving the documentation that we already have for the sort of extensions and updates as usual. But yeah, unless there are any other questions or comments folks want to go over, we could wrap it up a little early, but give folks another moment to chime in if they'd like. Anyone? All right. Well, thank you all for joining, and look forward to following up more on the mailing lists and on the call next month. Yeah, enjoy the holidays and the rest of the month. See you all later. Cheers.
All right, thanks.
Thanks, Phil.
Thanks.